Now, in the classification of basic elements, so far we discussed comments, white spaces, character set, program tokens. Now, data types are the fifth category. This is very crucial and very vast also. So, you have to focus on this deeply and thoroughly. Now, actually, all data types are classified into four groups. Those are fundamental data types, derived data types, user-defined data types, and finally, void. All data types, C data types, are classified into four groups: fundamental data types, derived data types, user-defined data types, and void. Before discussing this concept, once again I introduce what is data type. Now you understand the reality. What is a variable? Variable is a memory shelf or memory container. We have to choose the suitable container for the data. I gave an example to you. Somebody offers something to you. Then you have to choose the right container. On what basis you choose the container? Depending on the nature of the good, depending on the quantum of the good. Nature of the good means it may be liquid or it may be solid. For liquid means one type of container you use, and solid means other type of container you use. If quantum is less, one type of container you use. Quantum is more, use suitable container. Suppose 1 kg of rice or 50 kgs of rice. For both of them, you don't use same container. So, in the same manner, for all variables, we have to choose the right data type. Already extensively explained this concept in the second chapter. You choose the right data type, then because of classifying data type, then we can save the memory. Here, two options are there with us. One is all the data items, for all the data items, irrespective of their nature and quantum, allocating same amount of memory. And allocating differential amount of memory depending on their nature and quantum. Which method you follow? Already I gave you an example also. Tomorrow you are expecting 10 guests. Then you prepare food 10 into 10, 100 units. That for all the guests, equal amount of food. That is one. Second one is you categorize them, adults, children, babies, and preparing differential amount of food. Which one you follow? Even a illiterate housewife follow the second measure. And one thing, once upon a time, memory was very scarce. Memory was very limited. That's why it should be used prudently. But nowadays, memory has become a commodity. If you purchase a mobile and all that, 5 GB, 10 GB memory also they are giving freely. But memory is not the question. Here you see, this is one data item, int, let us say int. This is another data item, float. This is 4 bytes. This is 2 bytes. This is 4 bytes. So the processing time of this one is obviously more. That means if you categorize and put allocating both the data items 4, then unnecessarily you are wasting processing time. The processing is delayed. If you categorize, then whatever is suitable for integer, you can store in integer. Whatever is suitable for float, you store in float. So that's why data types are data type concept is created. All the data containers are classified. That is called data type. In this fundamental, several names are there. Primary data type, fundamental data type, primitive data type, built-in data type, all are referring same only. Actually, by name, don't confuse. In C and C++ also, for same thing, different names we use. Here, just remember, fundamental, primary, primitive, built-in. Why it is called built-in? Language, as part of it, they define. Now you see, int, float, char, already you have been using. You are not creating. Language created it, int. Then, if you, for the sake of integer values, you use int. For the sake of floating point values, use float. So that's why it is also called built-in data type. All these group are built-in data types. Now, after some time, I will explain this concept in detail. So here you see, just let us go to other categories. Int age you define. Then one value you can store. Always only one value you can store. Okay, one variable is created of 2 bytes. Its name is age, its type is int, and you can store one value. Suppose you have to store the ages of 5 students. Then what should you do? Int age 1, age 2, age 3, age 4, age 5. Okay, 5 also you are able to manage. To 100 students, it is very difficult, laborious, 1000 students. So, it is very difficult. So, one or few, it's okay. Individual variables, age 1, age 2, age 3, like that we can define. 100,000 and sometimes millions also we have to create. Then, this is not the right type. Right type means as far as this is concerned, storing one value, we don't have any complaint. So, how can we store set of values? For this purpose, a derived data type array is created. Then, now age, as far as this and this both are same. Now, see age 5, age 5. Now, one more extension we made. As far as this is concerned, both are same. One more extension with the square bracket 5. What does it mean? Now, this one block of memory is allocated for the on this declaration. On this declaration, 2 bytes memory is allocated as one block. On this declaration, 2 into 5, 10 bytes memory is allocated, and each one is called element. Element, this is age. This entire thing is called age. Its type is integer type array. This is called array. Array. How can you access this? Age 0, age 1, age 2, age 3, age 4. Already many times I explained, all computer index are 0 base index, not 1 base index. In this way, you can access. These are only just 5 elements. You can define 1000 elements also. Then as a single block, array is created. Its name is age. Its type is integer type array. Its type is int. Its name is age. Its name is also age. Its type is int. Its type is integer type array. That you remember as a single block. By using this subscript, we can access individual elements. These are called, each unit is called element. So, this is derived from the primary data type. That's why these are called secondary data type or derived data type. Derived data type. One block of memory in adjacent bytes is allocated. So, this is array is one of the derived data types. Some more derived data types are there. Later you can understand. Just I am explaining the concept. In forthcoming chapters, array, string, function, pointer, all these come under derived data type. So, by extension of primary data type, the secondary data type or derived data type is created. Okay. Now, user defined data type. User defined data type, why user defined data type is required? We have to see. Now, as far as array is concerned, one limitation is there. One grave limitation. What is that? This is integer type array. We can store only integer type values. We cannot store any floating point type value. Floating point type value. So, that is the basic limitation. That means floating point array means we can store only float. Character array means we can store only characters. That is the basic limitation. But this contains limitation because actually in real time we have to store different types of data. In some occasions we have to store different types of data. Then this is not suitable. Only same type of data items are there in array data structure we can store. So we can store in integer array, we can store integer type values only. In floating point array, we can store only floating point arrays, floating point values. That is the basic limitation. Suppose, let us take one case. One student's eligibility age is 15.5. 15.5. As a matter of practice, all students' ages we take as int. But for the eligibility criteria, according to eligibility criteria, admission for PU, then 15.5. But one student's age is exactly 15.5. But you cannot store here because you can store only integer values. You cannot store here. You cannot make it 16 also. Understand? So you must make it 15. 15 means he is not eligible. 15.5 means he is eligible. But you cannot store this. That is the basic limitation. Suppose if you convert the entire array as float, suppose 100 students are there. Originally, if it is integer type, 100 into 2, 200 bytes. The array's entire size is 200 bytes. Suppose if you convert into float, 100 into 4, 400 bytes. 400 bytes means here the problem, memory is not the constraint. The constraint is processing time. So instead of 200 bytes, because of one student, if you make it 400 bytes, the processing time is doubled. That point you remember. That's why which type of data type is required? We require user defined. That means whatever data you want, you must be in a position to store. For this purpose, through a data structure only you can explain. C provides one user defined data type and few more it provides, but with this example, with the reference to this data structure, I can explain what is the specialty of user defined. This is struct. Struct is the keyword. Structure. Now you see struct biodata. Now this is user defined data type. Now you take biodata. Biodata, do you feel it is a single item or multiple items? Actually, it contains multiple items, but entire container it is a single item. That's why we use biodata is. We never use biodata or. Understand? So biodata is. In this, you can put any type of item. Just for example sake, I show you. Now you put your name. You put age. You put your height. You put your weight. You put your marks in 5 papers. You put your date of birth. You put your address. In order to represent your biodata, many items you have to produce. Person to person it differs. So whatever items he wants and all that, all the items he put in this bag. You treat it like a bag, it is like a big container. In this no limitation, same type, different type, any type you can put. In order to represent your biodata, whatever elements are required, all elements you put. If you see that, now if you do not know also don't worry, I will tell you. Name. Name we can create a string. This is a derived data type or secondary data type. Age, you declare it as int. It is a primary data type. Primary data type. Then height, you declare it as a float. This is also a primary data type. Now weight, you declare it as a float. This is also primary data type. Marks 5, that means marks in 5 papers. Then this is an array. This is also a derived data type. Next, date of birth. Date of birth and don't go deeper, just understand. For date of birth, actually, this is like a structure like thing. Why? Suppose your date of birth is like this 11, 12, 19, 90. Now you see, these are not individual elements. These are three elements. All the three elements as one you submit. Now you see, compare biodata and date of birth. In biodata, a collection of 10, 20 items, you bundle and present. Then only your biodata is presented. Then what is type? Date of birth also, it contains the three items. All three together, you have to present as one item. Then only date of birth is represented. For this, what is the right type? Struct. Struct means user defined data type. Address also. Address contains nearly 10 items like your name, your door number, your street name, your area name, your city name, pin code, etc. and all that. All that as a single bundle you have to present. That's why what is the right type? Struct. Just one way you have to compare. If you don't understand also, don't worry. Biodata. In order to represent your biodata, what you are doing, a set of items you are bundling as one unit and you are presenting. Then only others can understand your profile. Understand? Now come to date of birth. Here also, three items together as one unit you have to present. Then only one can understand your date of birth. And address also is the similar nature. Around 10 items you bundle as one unit and present. Then only your address is represented. That's why for this also struct is required. Now you see, in biodata data type, that is user defined data type, which items you are putting primary data type, derived data type, as well as user defined data type. So no limitation. Whatever you want, you carry a bag and purchase vegetables, purchase provisions, purchase stationery, purchase cosmetics, everything you put in the bag. Like that, user defined data type does not have any limitations. Whatever data item you want to put in the container, you can put it. So that is user defined. User defined not only struct and union is there, type def is there, enum is there, all that little later in this chapter, mainly type def and enum. To user defined data type, I will explain. Same struct and union after some time in forthcoming chapters I explain. So the third group is user defined. Next, void. Actually, in the beginning of the first chapter, I told this void I explained in forthcoming chapters. Now the time has come. Now void. Void is a special type which is used with functions. Functions already in a limited way I explained. Already you know main function, clear screen, printf, scanf. 4 functions you know. Now there are many functions. This is because this is function oriented programming language. Mainly the basic component is function. So as far as functions are concerned, in the forthcoming chapters only you can learn about it fully. Functions can be classified into 3 groups. Now those are like in real life. Actually, you call a cleaner. You don't give anything, he does not return anything. Cleaner, one type of function, one type of specialist. You don't give anything, it does not return anything. That type of function you see, clear screen you take. Clear screen is the best example. Are you giving anything? If you give anything, you have to give it here. But it just clears output screen and go. It does not give anything to us. That's that type of thing is defined as void. It does not return anything, is specified by the void. Its type is a function, this type is void. In the same way, suppose this type of printf you see, printf in this form you see here A, B, C you are giving as a string argument. Then what it is doing? Simply it is reproducing the same. It reproducing the same without double quotes. Then whatever you have given, just simply it is reproducing. So it is also not returning anything. Suppose you call a painter, you give paint. You give paint, but he does not return anything. So its type is also void. Next, some other functions are there, like Tyler. You give cloth, he gives dress. That type of function. Many functions are like that. Square root is there. Square root, you give 100, it returns something. It returns 10. Then its type is int. Understand? So if it returns something like Tyler, and we have to declare its return type. Suppose a function does not return anything, its return type is void. Its return type is void. That clear screen is the best example. You know that it does not return; just it clears output screen and go. And in the same manner, printf in this format, it is not returning anything; just it writes and go. Type is void. So a function does not return anything; it should be declared with void. So main, why you declared void? It does not return anything to us. That's why its type is declared as void. So these are the 4 types. All data types are classified into 4 groups, 4 categories: fundamental data type, derived data type, user defined data type, and void.